Hello everyone, my name is Adini. Today I'm going to walk you through the fundamentals of cloud computing and critically its implications for our security postures as we embark on our cloud migration journey. Understanding this concept is vital for a smooth and secure transition, and I'll highlight key areas where our attention will be focused. At this core, cloud computing is about accessing IT resources like servers, storage, databases, networking, software, analytics, and intelligence over the internet. Instead of owning and maintaining your own computing infrastructure, think of it like electricity. You only consume it as needed and only pay for what you use. The key characteristics you see here is what truly differentiates cloud from traditional IT. On-demand self-service means we can provision resources quickly. Broad network access ensures we can connect from anywhere. Resource pooling allows providers to efficiently share resources, leading to cost saving. Rapid elasticity is crucial for scaling up and down based on demand, and measured service ensures we pay fairly for our consumptions. These benefits from cost saving and increased agility are driving our migration. Cloud services are typically delivered through different models, often referred to as X as a service or XaaS. This slide illustrates the most common ones. IaaS or infrastructure as a service gives us the most control, similar to renting a virtual data center where we can manage the operation system and application. PaaS or platform as a service takes away some of that infrastructure management, providing us with a ready to use platform to build and deploy our application. SaaS or software as a service is the most complete offering where the entire application is hosted and managed by the vendor. Think of your everyday web-based email. Finally, DaaS or desktop as a service provides virtual desktops, allowing users to access their network environment from any device. Our choice of service model will directly impact our level of control and consequently our security responsibilities, which we'll discuss later. Beyond the service model, we also consider how the cloud is deployed. As a private cloud is dedicated to a single organization, offering maximum control and often used for highly sensitive data or specific regulatory requirements. This could be on-prem or hosted by a third party. A public cloud, on the other hand, is owned or operated by a third-party provider and is available to the general public. This offers significant scalability and cost advantages due to shared infrastructure. Community clouds are shared by a specific group of organizations which with common interest, like compliance need within a particular industry. And finally, a hybrid cloud combines two or more of these models, allowing us to leverage the benefit of each. For example, keeping sensitive data in a private cloud while using the public cloud for scalable web applications. Our cloud strategy will likely evolve a hybrid approach to balance security, cost, and flexibility. A foundational technology underpinning cloud computing is virtualization. Virtualization allows a single physical server to run multiple isolated virtual machines, each acting as an independent computer. This is achieved through a hypervisor, which is a software that creates and runs these virtual machines. For cloud providers, virtualization is key for resource pooling, efficiently sharing powerful hardware amongst many customers, and enabling rapid elasticity, meaning we can quickly scale our resources up and down. For a security standpoint, it's critical that these virtualization platforms are robust and properly configured, as any compromise at the hypervisor level could potentially impact multiple virtualized environments. Cloud providers invest heavily in securing these platforms, and our understanding of this underlying technology is important. Service-oriented architecture, or SOA, is a crucial concept in modern software development and is particularly relevant in the cloud. It's a way of designing software applications as a collection of loosely coupled, reusable resources that can communicate with each other in the cloud. This often evolves into microservices architecture, where applications are broken down into even smaller independent services. The key enabler for this communication is APIs, or Application Programming Interface, which allows different services to interact. For us, this means greater agility in developing and deploying applications, as well as improved resilience because a problem in one small service is less likely to bring down the entire system. However, securing these numerous interconnected services and their APIs become a critical cybersecurity challenge requiring robust API security and continuous monitoring. Now let's compare our traditional on-prem approach with cloud computing across several key areas. When it comes to local resource requirements, on-prem means significant upfront capital investments in hardware, dedicated physical space, and a substantial IT team for maintenance. In the cloud, these upfront costs are drastically reduced, shifting to an operational expense model. We leverage the provider's infrastructure, requiring far less internal IT burden for physical hardware management. Regarding local control, on-prem gives us complete oversight from the physical hardware up to our applications. In the cloud, the transition to a shared responsibility model where the provider handles certain aspects and we manage others, depending on the service model. Finally, network requirements are primarily internal for on-prem system, whereas cloud computing is entirely reliant on a robust and reliant internet connection for all access and operation. Moving to security, this is where the differences become most pronounced and where our attention must be sharply focused. For local infrastructure, our security posture is largely based on a defined perimeter, managing physical access and traditional network defenses. In the cloud, the attack surface expands. We face risks like data breaches, misconfiguration, and insecure API, while which become primary attack vector. Mitigating strategy shift from pure internal control to include strong identity and access management, extensive encryptions, and leverage the cloud provider security features. The overall vulnerability landscape changes. While we gain the immense security investment of major cloud providers, we also face new challenges like the shared responsibility model and potential multi-tenant exposure. Misconfiguration are particularly rampant, often due to oversight and complexities, and insecure APIs and pure access management are constant targets. Understanding these challenges and adopting proactive security measures is paramount. Beyond the technical aspect, there are crucial broader considerations for our cloud migration. In security, the shared responsibility model is fundamental. The cloud provider is responsible for the security of the cloud, meaning underlying infrastructure, while we are responsible for the security in the cloud, meaning our data, applications, and configurations. The distinction is vital for assigning accountability. Compliance with regulations like GDPR or HIPAA doesn't disappear in the cloud. It becomes a shared effort with the provider. Our incident response plan also needs to be adapted to the cloud context. For storage, cloud offers immense scalability and durability, but we must understand the cost implications, including egress fee for moving data out of the cloud and strategize data tier for cost optimization. Finally, legal and privacy issues are significant. Data residency law can dictate where our data must physically reside, and cross-border data transfer requires careful attention to international regulations. We must also carefully review contract for data ownership clauses and be aware of potential vendor lock-in challenges. This slide lists the scholarly resources and reputable online articles that inform the content of this presentation. These references provide further in-depth information on cloud computing fundamentals, security challenges, and legal consideration. I encourage you to explore them if you wish to delve deeper into any of the topic we've covered today.